Hello everyone, I just wanted to go ahead and start off and talk to you guys a little bit about calculus. One of the biggest topics you guys are going to see from calculus, specifically in your first month of calculus, is going to have to do with limits. Limits are what is going to lead to your eventual definition of a derivative, and it's actually going to be something that's going to be super useful to each and every one of you. If any of you guys ever want to get really good at working with the stock market and you guys can't afford very expensive software monthly, this is going to be one of the best ways you're able to do it. And if you guys learn basic calc, then you guys will understand what those programs are doing. And there are a ton of applications to it. So what we're going to be doing today is we're going to be starting off with our introduction. I'm going to break this apart into two parts. First one is going to be an intro to limits. We're going to be using tables to find limits, and then towards the end of this, we're going to start understanding what taking a limit from the left and right side means. So the first thing is, suppose you and a friend are walking along the graph of the function f of x equals x squared minus 4 over x minus 2. Now this graph, what we notice is we have a quadratic over a linear function, but there's a little problem here. What number can we not plug in here? If you guys are looking at it, we can't divide by 0, so if I plug in 2, this function is going to be undefined. Okay, so if you and your friend reach 2, you will fall through the hole and splatter onto the x-axis. Obviously, there's a problem. There is a problem at x equals 2. But what happens along the graph as you get very, very close to x equals 2? And this is going to be the basic idea. What happens? So what happens, let me go ahead and change my color. What happens when we walk very close to x equals 2? And this is going to lend us to the idea of a limit. So here's this situation. If you guys notice, if you divide a quadratic by a linear, you're going to get a linear function. And this basic idea is just what we were talking about. You and your friend are walking up and down, and you're going to meet at x equals 2. Well, what happens is, since it's undefined there, you have a hole. We have a hole here where this is undefined. And the person will fall through at that point. Your function's not defined there. But what's happening once you guys approach? Where's our function going to be at? So what we're going to do is we're going to go ahead and look at what's happening to the left and what's happening to the right, and we're going to see a pattern unfold, okay? So the first thing you guys are going to notice here is in this table, when you plug in 1.99, 1.999, 1.99999, that's very close to x equals 2. And when you look at it, it's getting really, really close to 4. Okay, and then what happens if you're looking at the right side, we plug in 2.01, 2.001, very, very, very close to 2, once again on the x-axis, and you're going to find you get 4.001. So when we're looking at this, our limit as x approaches 2, this is the idea, our limit of this entire function as x approaches 2 is equal to 4, okay? The limit is equal to 4. So when we write this out, the limit as x approaches 2 of x squared minus 4 over x minus 2, this is going to be equal to 4. Okay? This is a very, very important concept. Does our function, does it exist at that point? No, we have a hole there. But our limit exists. Okay, and as we go on a little further, that idea of this limit is going to be important, and you guys are going to start to see a little bit more. So the first kind of thing we're going to do is read the definition, and then we're going to go through and do two examples together. So with this, when you guys are reading through it, suppose that f is a function. F is a function defined on some open interval containing a number a. The function f may or may not be defined at a. So the limit notation is written, the limit as x approaches a of the function f of x is equal to L. And this is read, once again, it says it all right here. This means that as x gets closer to a, but remains unequal to a, the corresponding value of f of x gets really close to L. Okay, so what does that mean? Let's go ahead and work through this. So essentially, if we're plugging in a value and we're trying to see this, we're going to see a couple of different cases. We're going to use a case like in the last case where our function's undefined at, in this case, 0, and where it is defined. What's the difference? So with this, when we're working with this first one, we're going to go ahead and we're going to take and draw out a little table. And in this table, we're going to have our x's, and then we're going to have our f of x's, our function values. Okay, and when we plug into this, we're going to see a couple of different things as we go. I need to make this 2 more in length. Okay, there we go. So with this, we're going to plug in some number that's very, very close to 4. So just like in the last case, we're going to plug in 3.99, 3.999, and then we're going to get really, really close to 4. Okay, and then what happens here in the middle? Okay, so with this, for our next part, we're also plugging in 4.0001, 4.001, and we're going to try to see what's happening on each side of this. So when we plug this in, we're going to get 47. When we plug into it in our calculator, we're going to get 47.76. Then we're going to get 47.976. Then we're going to get 47.9976. On this side, we're going to get 48.024. 48. Oh, there's 2 zeros. Sorry. 48.024. And what it looks like when we're finding this is the limit as we go from the left and the limit as we come from the right. It looks like on each side they're both approaching what number? It looked like they're approaching 48. Okay, so this approaches 4. This actually approaches 48. It's not undefined at that point. Okay. So what I want you guys to do is I want you guys to go and take a moment and do the same exact thing on checkpoint 1 for me. So I'm going to give you guys a moment. All right. Now on the next side of things, we're going to find with this one, we're plugging in a value for which the function is undefined at. And we're going to see what happens as we take our limit from the left side and our limit from the right side. Okay, so we're going to go ahead and start out and make a 7 slots for this 1, 2, 3, 4, 5, 6, 7. Good. So then this is x, and this is f of x. Once again, we're approaching 0 in the center. So I messed up again. Oh well. We're approaching 0 in the center, and we're trying to figure out what happens here, but we're undefined at 0 because, once again, when you plug in 0 into the denominator, and you divide by it, you're going to get an undefined function. So from that, we're going to go ahead and plug in a few values from the left. So we're going to plug in negative 0.03, negative 0.02, negative 0.01. And then on this side, we're going to plug in 0.01, 0.02, 0.03. And we're going to see what happens to this function. So we're going to go ahead and get out your calculators. We're going to plug this in. If you plug in negative 0.03, you're going to get 0.99985. Then you're going to get 0.99993. Then you're going to get 0.99998. Okay, and when you're looking to the right side, we're doing the same sort of thing. When we plug this in, we're going to get 0.99998, 0.99993, and then 0.99985. Okay, so if we're thinking about what's happening here, this function's getting really close to 1. So the function does not exist at 0, but our limit is going to be equal to 1. Why? Because our limit from the left is going to be equal to our limit from the right. They're both approaching the same value, which is 1. Okay. I'm going to go ahead and end this video, and you guys are going to have a second part afterwards. Feel free to take your time. Please don't forget to send me a picture of your actual checkpoints. I want to see at least one picture from each and every one of you. Thank you guys.